solving quadratic equations. And this applies to IGCSE math for extended math, international math, and even ad math. And to solve these equations, there are three main methods. And also, what is a quadratic expression or quadratic equation is nothing but ax squared plus bx plus c equal to 0 because it's an equation. And the main criteria is that a cannot be equal to 0. Let's assume that a was equal to 0. That will leave us with only this, which is a linear equation, not a quadratic equation. So this is the criteria for ax squared plus bx plus c, that a is not equal to 0. The first method is completing the square, which is the most complicated method because you have to derive because of this one simple step. So I'm just going to show you a general method like this, and this was actually the method I was used to derive the quadratic formula we use. So I'm just going to basically deriving that formula. For this method to work, we have to divide everything by the coefficient of x squared to basically get x plus something instead of 2x plus something. So you have to divide everything by a on the left side and on the right side, which will give us x squared plus bx by a plus c by a equal to 0. This is the first step. This is the first step. The second step is to convert this into its squared form. And to do that, you just take x plus the coefficient of b of x, which is b by a in this case, and then you half that. So this will be what? b by 2a, and you square that. And let's just expand this binomial over here. So x plus b by 2a whole squared is going to be x squared over here, plus b by 2a into 2 into x. That's the middle term, right? So this 2 cancels out to give us bx by a, which is what we had over here. However, we have another term which is b squared by 4a squared, which is something that we don't want, so we're going to subtract it from this side over here. So minus b squared by 4a squared plus c by a is equal to 0. Now, after coming this far, the only thing we need to do is make x over here the subject of the formula. And to do that, we are going to not expand this over here, not going to expand the square. We are going to use the square root method. So we are going to take this over here to the other side, square root plus minus, and subtract b by 2a. So the final answer that we're going to get is going to be x is equal to minus b by 2a plus minus the square root of, take the LCM of this, which is going to be 4a squared. This is going to be b squared, and c has to be multiplied with 4a, so minus 4ac. Now over here we are just going to take the square root of 4a squared is going to be, that square root is going to be 2a again, and this will give us minus b by 2a plus minus the root of b squared minus 4ac, because they are the same common denominator, and this is nothing but the quadratic formula. Right, now what was the main step that I followed? I will be erasing everything and just showing you step by step in a more simpler manner. So if you have ax squared plus bx plus c equal to 0, you divide everything by a to get x squared plus bx by a plus c by a equal to 0. And the next thing is just take this as x plus half of the coefficient of this, which is b by 2a, square that, subtract b squared by 4a squared, and you add c by a. That's the main method, and then you make x the subject of the formula. So let's do a few example solves. X squared plus 2x plus 5. In this case, we already have the coefficient of x squared as 1, so we don't do anything over there. So the first thing we do is to divide everything by 1, which we don't need to do. Next thing is going to be x plus the half of 2, which is 1. Yeah, x plus 1 whole squared is what? X plus 1 whole squared is nothing but x squared plus 2x plus 1. So we're going to subtract 1. So we have a plus 5 minus 1. So x plus 1 whole squared plus 4. This is nothing but this over here, which is x squared plus 2x plus 5. That is different ways of writing the same statement. Next, x squared plus 4x plus 3. Same, the coefficient of x squared is 1, so we don't need to divide it by anything. So we just do x plus the half of 4, which is 2. So x plus 2 whole squared. And you have to subtract the square of this, which is nothing but 4 plus 3. Which is going to be x plus 2 whole squared minus 1. Next, x squared plus x plus 3. This one is going to be a bit different, and the reason behind this is because instead of having 2 divided by 2 or 4 divided by 2, we are going to have 1 divided by 2 in the square form. So it's going to be x plus half of 1 squared plus 3 minus 1 by 2 squared. What is 1 by 2 squared? 1 by 2 squared is nothing but 1 squared by 2 squared, which is 1 by 4. And then we can write 3 as nothing but 12 by 12 minus minus 1 by 4 will become 3 over here, which will just end up being 9 by 12 or 3 by 4, which seems very wrong. So I'm gonna do that again. One by 2 squared is going to be 1 by 4, and that is going to be, yeah, so it's going to be 12 by 4 minus 1 by 4, which is going to be 11 by 4. That's going to be the answer. So it's going to be x plus 1 by 2 whole squared plus this. That's going to be the same thing as that. The next method is the quadratic formula, and we already found out the quadratic formula to be x is equal to minus b plus minus the root of b squared minus 4ac divided by 2a. Another simplified formula for this is nothing but minus b plus minus the root of the discriminant divided by 2a. And this is nothing but the delta symbol, which is the same thing as the discriminant, which is nothing but b squared minus 4ac. And this discriminant is in itself very, very useful. I doubt that there will be any questions regarding this in international math, but there will be in ad math. So basically, b squared minus 4ac is equal to the discriminant. And we have three different possibilities for the discriminant. The discriminant can be less than 0, it can be equal to 0, and it can be greater than 0. If the discriminant is less than 0, then there are no real solutions. If it is equal to 0, then there is only one real solution. One real solution, or you can say two similar solutions, or two solutions but they are the same. And if it is greater than 0, then there will be two real solutions which are distinct. So those are the different possibilities for the values of discriminant, and this is one application of the discriminant. So now let's find the value of x using the quadratic formula. So this is going to be equal to 0, and we're just going to use minus b plus minus the root of b squared minus 4 ac divided by 2a. Now if you notice, 4 into 5 is 20, and 4 minus 20 is minus 16, and that is the discriminant is less than 0. And like I said before, this means that there are no real solutions. Yeah, x squared plus 4x plus 3. For this one, just use a similar idea. This is equal to 0, so we got minus b plus minus the root of 16 minus 4 into 3 into 1 divided by 2 into 1. So this is going to be minus 4 plus minus the root of 16 minus 4 into 3. 4 into 3 is 12. 16 minus 12 is 4 by 2. So this is going to be minus 4 plus 2, which is minus 2, divided by 2 is minus 1 by 2. And 4, that's going to be minus 2 also. So minus 4 minus 2 is going to be minus 6, divided by 2 is minus 3. So those are the answers. Now, I want to go back to this one over here and show you in the quadratic formula. If we equate x plus 1 whole square plus 4 equal to 0, this is going to go over there to give us x plus 1 whole square is equal to minus 4. And negative numbers don't have any roots. That is why there'll be no real solution. The solution will be imaginary or complex, which we don't need to know. Next one is x squared plus x plus 3 equal to 0. So x is equal to minus b plus minus the root of b squared minus 4 into this divided by 2 into this. And again, look at this. This is going to be a discriminant which is less than 0 because this is going to be 1 minus 12, which is minus 11. That is something, again, no real solutions. Now the last method is factorization, and this is by far the most annoying method. If you need to factorize this, basically when it comes to factorization, the main idea is that it's going to be x squared plus ax plus bx minus 63 in this case. Yeah, ax plus bx has to add up to 2x. So this is going to be a plus b is equal to 2. That is one criteria, that the coefficient of x is going to be 2 in this case, is going to be the sum of the two values that we're adding. So it's going to factorize into that. The other criteria is that when you multiply a and b, you should get the product of the coefficient over here and the constant over here. So this is going to be 1 into minus 63. So that is the criteria that we need to look for. So basically what we can do is factorize minus 63. That's the fastest way to go by it. And the answer is going to be 9 and 7. 9 and minus 7. So I'm going to write this as x squared plus 9x minus 7x minus 63. X common, x plus 9 minus 7, x plus 9. So we get x plus 9 into x minus 7 is equal to 0. Now the idea over here is to use the simple logic that either this is equal to 0 or this is equal to 0. If x plus 9 is equal to 0, then we get x is equal to minus 9. And if x minus 7 is equal to 0, then we get x equal to 7. So that is the solution for that factorization problem. But the question only asks us to factorize it, so we stop over here. So this is going to be the answer. The next question will ask us for the solutions. Now over here, this is a much more complicated one, I guess. So this is going to be 10r squared minus 23r plus 9 is equal to 0. This specifically says solve by factorization. If it did not say that, then we could simply use the completing the square method, which would be a bit harder. We can just use the quadratic form, which is the easiest of the lot. So let's start solving this. I'm going to say that is nothing but 10r squared minus AR plus BR plus 9 is equal to 0, and A plus B is equal to minus 23, and A into B is equal to 90. 9 into 10 is 90. So let's factorize 90. 90 is nothing but 10 into 9, and that, okay, let's write it over here. I'm gonna draw so 90 over here, 1 into 90, 2 into 45, 3 into 30, 4, it's not a multiple of 4, 5, yeah, 5 into 16, use your calculator, it's not that, so maybe 90 divided by 5 is 15, then 5, no, 6, check if it's 6 divided by 6, it is, this is going to be It's 6 into 15, not 5 into 15. Okay, 90 divided by 5 is 18, and 6 into 90 divided by 6 is 15. And if you just stop over here, these will be the answers. So minus 5 minus 18 is equal to minus 23, and minus 5 into minus 18 is equal to 90. So that's going to be the answer. We just factorize it now. So we take, instead of taking just r common, we can take 5r common. This will be r minus 1, and then you can take minus 9 common, r minus 1 equal to 0. So we get, because these two are the same, we can just write it as 5r minus 9 r minus 1 equal to 0. So 5r minus 9 is equal to 0, that gives us r is equal to 9 by 5, and r is equal to 1. So those were the practice problems on the quadratic equation solving methods. Now, if you're in extended math, you can just use the calculator for this as well. You can just go to the mode function and go to equation and choose ax squared plus bx plus c, which is the quadratic value, right? So just go there, and you can just put the coefficients over here. So if I put 10, sorry, if I put 10, 23, and 9, so 10 minus 23 and 9 equal to 0, I get x equal to 9 by 5 and 1 by 2. Mm, so that's one thing you can do. You can check your answers and see if they're right. So here it turns out that I'm wrong somewhere. So let's see where I went wrong. 10r squared minus 5r minus 18r plus 9 is equal to 0. 5r common. This is going to be 2r over here, is it? Yeah. Um, that's where I went wrong. So this is going to be a 2r, and this is going to be a 2r. So this is going to be 2, divide that 1 by 2. So that's one thing you can do. If you're in international math, then you can use the graphic calculator and you can simply plot it on the graphing function, or you can go to the equation function on the menu and choose polynomial degree 2, and then put in the coefficients, and you'll get the answer there as well. And that'll be it for factorization of different forms, different methods of factorization.